Hello and welcome everybody to another webinar here at Fronius International. So today's topic is all about off-grid solutions together with the photovoltaic system. So on the one hand side, we are going to talk about PV genset solutions, single or multiple ones together with a photovoltaic system. And then the second half of today's webinar is all about microgrid. We're focusing a little bit on Victron systems, but just that you know, there are multiple compatible third-party units that you can use for that. All right, so before we start, a quick introduction. My name is Christoph Schillinger. I'm from Team Trainings and Education, and I will guide you through today's webinar. And I'm assisted by my colleague, Michael. He's behind the camera today and answering your chat questions. And also at the end of the webinar, he will come forth and we will discuss a few of your questions live then. All right. Yeah, before we start, also one last organizational topic that I already mentioned, basically. If you have questions, use the chat function on the right-hand side of your screen. Just send them through. We are then happy to answer them in writing and then at the end verbally as well. Also, please note this webinar will be recorded so you can rewatch it anytime afterwards. You will get an email for that. And also you will find this in the next 2 weeks on YouTube. All right, so let's get started with the first topic, the PV genset solutions. Yeah, what customer segments are we talking about with this solution? Basically, big scale solutions. So high loads like you would need in a factory, in tourism, like a resort or something, mining or food processing. So everywhere where we need really high energy, then we stick or mostly stick with PV genset solutions, and especially there where we have no or weak grid. So what components do we have in a PV genset system, and how do we as Fronius define such a system? Of course, we have Fronius inverters for the photovoltaic system to convert DC to AC and to support, number 2 in this row, the diesel genset. So as mentioned, this can be a single genset solution or a multiple ones. So multi-megawatt systems can be provided here. Then we have a controlling mechanism because of course we need to make sure that there is a balance in there. We talk about that in a minute. And last but not least, we have the load itself. Okay, so consisting of those components, we then can differentiate between a low penetration PV genset solution and a high penetration system. Low penetration basically means we have compared to the load, a very small PV generator on the roof contributing to the system. So like the red curve you can see here, this is a very small amount of energy coming from the PV system, and there is no need to control or regulate any of the PV system's output because it's very small in comparison. So, sorry. Oh, we have a stuck screen. I'm very sorry for that. Now it works. Sorry for that. We now should have a screen again. As I mentioned, low penetration system compared to the PV generator or to the load, we have a very small PV generator on the roof. So low penetration does not need any controlling at all. And then in comparison to that, there is the high penetration PV genset solution where, as the name already indicates, we have a very big generator on the roof. And at some point, we might have a lot of surplus energy, even more than we have load to supply to. So in this case, we then have to control the output of the inverters so that the diesel generator can run at the minimum load. This we can see here. So the light gray area, this would be a generator or the energy out of the generator, and the dark gray area would be supplemented by the PV system. So the red curve equals the dark gray area. And as you can see, at some point during noon, we have so much energy because sun is at the perfect position for the PV system. And then we need to regulate down the output power of the inverter in order to leave the PV, the genset on a minimum load. This would be the straight line at the bottom here. And yeah, so high penetration system, I think I have a note here, a dynamic control of the PV power production is necessary. Otherwise, we would have a backflow and it could destroy either the inverters or the generator. Of course, not good. All right, so we differentiate between low and high penetration. And then, of course, we have a schematic here picturing a PV-Genset advanced and professional solution. And what we mean by that is, maybe we start with the advanced solution. We have the inverters, the generator, we have the genset solutions, single or multiple ones, and then the most important topic, the solar controller, in order to give orders to the inverters to regulate down, to ramp up if necessary. Then we have a grid or not, depending on what we have. Maybe it's a weak grid and then we just disconnect and run off grid with the generators. We have the loads, of course, and it's also optional to have batteries included. These can be utility scale as well. Yeah, and depending on the amount of controllers and the advancedness of the controllers, we talk about the simpler advanced solution. Here we just have the solar controller in there. And on the professional solution, we then talk about the solar controller and external controllers for every genset as well from one company. So advanced and professional, the only difference is that we have multiple of those controllers, even for the gensets, and they are talking to each other to have the perfect curtailment of your system. So after that slide, I quickly have a good comparison what ranges we typically choose advanced and professional, but just that you know the difference is that everything comes out of one manufacturer, and it also includes the genset controllers in the professional solution. Yeah, and as we have seen before, those will be the main tasks of the PV-Genset controller, to have the protection of the diesel generators by regulating the power. Because we have, like I mentioned, a PV-Genset minimum load that we do not want to fall below. And that means that at some point, inverter power needs to be cut down and curtailed. So basically, we're talking about the protection, a security component in the system. So peak load demand. All right, so this should also answer a few of the questions right now. Why PV-Genset at all? Because we have a stability of the entire system, the entire PV-Genset system. We have a very easy integration of an existing genset. You simply plant the PV generator with the inverters next to it. You connect it AC coupled, and then you just have to set the controller, and that's it. You then have the possibility to save a lot of money. I will show you in the next slide a reference system that was installed back in the day in 2014, and boy, does it save money and fuel. And yeah, this is of course one of the biggest benefits of this solution. And then we can also see in this reference a rapid amortization. So it is a real business case. We decouple from the fossil fuel, of course, as well, and reduce the carbon footprint. So as promised, the reference system, here we're talking about an agricultural system in Lebanon, and it's about 150 kilowatt peak big, with a generator, a single generator with 280 kilovolt amps. And yeah, we're talking about irrigation systems, so a lot of pumps and a lot of load demand. And with the positioning of the PV generator there, we have an annual yield of 216,000 kilowatt hours that we can contribute to the generator there. And this equals in 114 tons of CO2 equivalent per year and a 40% degree of self-sufficiency. I have cut this down to a few numbers for you so that you can see what this means in terms of money. So this would be the cost for the PV system, 15 cents per kilowatt hour, and this would be the cost for a kilowatt hour of fuel, basically, for the diesel generator. We have heard this is the size of the PV installed capacity and the yield that comes with it. And the total cost of the system would be around, or back in the day, it was 216,000 euros. The customer paid this, and then he planted the PV generator on this mounting rack. But because he saves so much fuel, he has savings, annual savings of 45,000 euros. So within 5 years, he had the return on investment already in check. So the amortization was done by the 5th year. And from there on, he get nearly 70,000 euros plus, simply by having the system on site and supporting the diesel generator. So it really does make sense. It really is a real business case. Of course, we have lots of more reference systems for you to check out if you want. On our homepage, you simply can select reference systems and select by diesel generator or PV genset solutions, and then you can check them out for yourself if you want. All right, but if you are at the beginning of a system like that, to implement a system like that, then you can get started by filling out a Fronius PV genset checklist if you want. You can get this as well from our homepage, and you then send it through to us. We then have a planning support with Homer Simulation. That's a software tool where we can do a rough estimation on what you need, what size, and so on, and what you can expect out of it. And of course, we can hand you through to a third-party diesel generator controlling manufacturer. Just to name a few, there would be Elam, Dive, and much more. Comap, for example, would be a third one. All right, so this is how you can get started on such a PV genset solution. And to give you some hints about how to design and how to do the system, I have some recommendations for you. The first one is never fall below 30% of minimum genset load. The reason is that every diesel generator, every genset has its minimum load, which it runs on the perfect efficiency rate. So there is a certain limit, an RPM limit, and if you go further below, it means a lot more wearing of the system and a lower efficiency. So typically it's around 30%, unless it's stated otherwise by the manufacturer, of course. Vice versa, of course, we need to also make sure that the maximum AC inverter power should not exceed 60 to 70% of the genset power. And of course, like in every system, know your load profile. Make sure that you have an annual overview of what's going on, what's the maximum, the minimum load, what's the average and daytime load, for example. Is there a seasonal change that you can account for? And then after you know that, then you can design a little bit better the size of inverter and genset solution. All right, that's the first topic. And the second topic is do a DC to AC ratio to the maximum. Really push it to the limit. You might have heard of the 150% over-dimensioning possibility on our inverters. This is meant by that. Make sure that you have the biggest PV generator on the inverter. So for example, on a 100 kV Tauro inverter, you can put up a 150 kilowatt peak system. And why you want to do that is to really get the maximum out of it. The inverter will not produce more than 100 kV, but the 150 wouldn't occur anyway at every time of the day, so why not push it to the maximum? There is no warranty loss or whatsoever. And also, you might want to consider an east-west installation to really synchronize the load to the production. So because on the east-west installation, you have earlier in the day and later in the day a higher production, which can be curtailed even better for your load profile. And we have heard about PV-Genset Advanced and Professional, which require involvement of third-party controllers and meters. Like I mentioned, ComMap, Dive, and Elim would be partners for that. Yeah, power ranges would be for the advanced solution up to 2 megawatt. Like I mentioned, then we have just a simple controller which gives the demands to the inverters. And if we want really multi-megawatt systems up to 5 megawatt, for example, then we typically go for a professional solution, because then it does make sense to have also a controller unit on the generator itself, on the diesel generator. All right, so but you can see the limit is quite high up, so you can do quite big systems with PV-Genset solutions there. All right, components or inverters that can be used for that would be the Fronius Taro. Of course, big systems ask for a big inverter, and with the Taro and the Taro Echo, we can hand you a 50 or 100 kilowatt inverter for that matter. There are different options, different variants for this product. There is even another online training just for that product. So if you're interested, check that out, because it gives you a lot of options and opportunities, like a direct options with direct MC4 connections of the PV strings, or a pre-combined version where you have big DC cables that you can connect on so-called V-clamps. So that's just two of the options that you can have with this product. I don't want to go into detail in this webinar, but just know that you can check it out on YouTube, and on our homepage you can register for the next online training or webinar of this product. Yeah, beside the Taro, we also have the Snap Inverter series, which is still pretty much used for that matter. We have the Fronius Simo, the big one from 10 to 20 kilowatt, perfectly used for a PV-Genset solution. And then we have the Fronius Echo, which is basically the Fronius Simo with a little bit of components pulled out, and that makes it lighter and more cost efficient. And it's coming in the power classes 25 and 27 kilowatt. Or you can combine those two or those three with the Taro all in one system if you would like. So all of this is possible. Yeah, in regards to communication, we are talking about a Modbus TCP, a Modbus RTU, or a Fronius Solar API connection that we can do, for example, in this case to Elim. We have here in the picture Elim hybrid fuel saver, and we are connected to those. And this unit then gives the demand to the inverter to regulate down, to shut down, or to ramp up. And what you can also do is you can have a separate connection to the internet, to a router on site, and then to bring the system online to SolarWeb. So you can have both the monitoring of Elim, for example, and the monitoring from Fronius in order to have the state codes and server service messages ready for the inverter. So really a cool system, just connected parallel to the controller and to the internet, and have both monitoring options. Yeah, the same thing goes, of course, for the Snap inverters, same thing. But the difference is just that the Snap inverter has to be equipped with at least one Data Manager 2.0 card in order to have this connection to the hybrid fuel saver and to the router to the internet. All right. Yeah, so actually that's our finishing line for the PV-Genset solution. I hope I could answer most or some of your questions at least, but we will see at the end of the webinar how this worked out for me. And in the meantime, we head on into the second topic for today, the microgrid and backup solution. So Again, the question, how is a microgrid solution defined by Fronius? What components do you find in there? Of course, the Fronius inverter and the generator on the roof. Then we are talking about inverter chargers. In this case, you can obviously see the manufacturer with the blue cover. It's Victron Energy in this case. Then we are talking about a battery and a load, of course. So there is no diesel generator necessary. You can optionally integrate it, but it's not necessary. And the question, why do you want this solution instead of an PV-Genset solution, for example? You again have independency from an unstable or non-existing grid, number one. Then the big difference between a generator PV-Genset solution and the microgrid is that it is a silent power for off-grid locations. No generator has to run. It's all silent with batteries and PV generator on the roof. And it gives you 24 hours of sun at its final destination in order to reduce carbon footprint, of course. So the components we have seen, the Victron unit on the left-hand side and our compatible product series for that, the snap inverter, SIMO and Echo, and also the Primo can be used for that, the single phase snap inverter, and as well our Gen 24 product, SIMO or Primo. We also have the Tauro, of course, which can be used in order to have it integrated in a microgrid system. But please note, it's not listed here because we didn't have the testings done right now, but it works, it runs. We have some systems out there that have used the Tauro for microgrid systems. Yeah, the customer segment is kind of similar, but smaller in the load profile. So like small businesses, ecotourism and resource, but with not such a big load profile, a homeowner or a village electrification. So all of these come into play when we talk about microgrid solutions. Yeah, and the solution itself looks like this. We have the backup capable and scalable with inverter chargers, which do form the grid basically. Because if you think about the Fronius inverters, they do always need some kind of frequency and voltage to synchronize to. We're not able to build up the grid 24 hours a day, 7 days a week. For that, we have Victron, and then Fronius just synchronizes onto it. And this gives us an autonomous control mechanism with a so-called frequency shift to ensure a proper functioning system. I will show you in the next slide how this works. And then we have the following benefits: to maximize the solar share, to use the energy more efficiently during on-peak times. And of course, we save surplus energy for off-peak periods because we store the surplus energy in batteries. And we have the maximum independency from fossil fuel powered diesel generators. So again, you can integrate it, a diesel generator, but most of the time you would not need it. Okay, and this is how it works now. You have a grid or not. So let's say there is a grid, then you have the inverter charger. And on the inverter charger, you connect the AC to the loads. And in between load and inverter charger, you then have the possibility to connect the Fronius inverter. Like every system you would do on a grid parallel solution, you just do an AC coupling. That's basically it. And then there are a few more options you can do. For example, you have the possibility to integrate a low voltage battery here. Then the option would be to connect a solar charge controller from Victron with a few modules connected onto that in order to have a better charging efficiency rate, because of course in this case we would charge from those modules directly from DC to our batteries and not from the Fronius inverter DC to AC, AC to DC to the batteries. So a few options are here possible for you. And last but not least, we have then also a monitoring unit from Victron itself, the GX component. And again, like with the PV-Genset solution, you can have both. You can have the solar web monitoring and the Victron monitoring together in parallel. That's not a problem here. Okay, but now comes a really important question, which everyone should raise by now. How do we work the problem out if we have a lot of surplus energy, the battery is full, and there is no grid? What do we do with the energy? And the answer to that question is we have a frequency controlled power reduction, because of course we need to reduce the output power of the Fronius inverter at any point. Because if the battery is full and we have nowhere to go, the load is not big enough and there is no grid, then we would have an overproduction and kill something, explode something, and that's of course not good. And with the frequency controlled power reduction, we have an automatically increase of the frequency as soon as we come to 100% state of charge of the battery. So this is done by the inverter charger from Victron itself. It measures, of course, voltage and current of the battery, and then it can indicate, okay, we are nearly 95% state of charge of the batteries, which means I need to increase the frequency by a little. And I can show you here on the screen how this looks like. By increasing the frequency, or this would be state of charge here, state of charge between 90 and 100%. And here on the bottom, we can see frequency from 50 to 53 Hertz. And in this range, it would then slowly but steady increase it. And by that increase, the inverter knows, okay, at 51 Hertz, I need to regulate down and down and down until we have 100% state of charge, and I need to shut down completely. So it's a very simple but reliable solution that works together with Victron and Fronius, and the preset for that is already implemented. You just have to activate it on the display of the Snap inverter or on the web interface of the Gen24 and Taro products. And this is called Microgrid 50 Hertz or 60 Hertz. And with that, this frequency controlled power reduction is automatically activated. Very cool feature, can highly recommend to do this, and very safe. Yeah, and as you can see, we have a long-term partnership with Victron with those kind of technical adaptations. But it's not even the frequency watt curve that we do. It's also the fact that we are implemented with a small icon, with a symbol in Victron's monitoring unit. You can even spot a snap inverter icon and know exactly how much does Fronius produce and so on. So this really makes a very cool optical view for the customer. So very cool adaptations, strong partnership, and also a technical support committee. So if there is a system out there and you have a problem with it, there is no finger pointing from Victron or Fronius. It's their fault or it's their fault. We try to then find a good solution which works for you without do finger pointing. And we have global trainings and education like this webinar. You also will find this solution or this kind of education on the side of Victron as well. They have a cool e-learning platform, very good webinars and online trainings in that matter. So I can highly recommend to check that out as well if you are interested. Okay, last but not least, I want to show you again a reference system. This one is in Spain and it's basically a pig farm, and they have kind of an off-grid solution or at least a very unstable grid there. And yeah, they opt in for an 82 kilowatt peak system with Fronius Salmo snap inverters and 6 of the Victron Quattro units. So this is the inverter charger that we have seen beforehand. They have charge controllers directly charging up their batteries from Victron, and the battery unit itself is 2 times 1550 amp hours batteries. They even have a backup solution for the backup solution in the matter of a diesel generator. And the diesel generator would simply kick in if there is no power from the batteries, if there is no sun shining, then the diesel generator would kick in at last. Yeah, this thing was commissioned in 2016 already and runs smoothly and steady. So as well as the other reference before, a very successful unit. Yeah, and it's not just that. It's not just this solution that I want to show you. We have done this more than 1,000 times, and this is just a quick and small collection of some of the reference systems that we did all over the world, where we have weak grid, no grid, or even just a customer who is interested in having a completely independent power supply. So we can look back into a very cool collection of successfully installed systems here. Okay, I have mentioned this already. We have a special country setup for this frequency shifting, and this is called microgrid, 50 or 60 hertz. And this setups allows us then to work perfectly in microgrid and also on PV-Genset solutions. Please note that you would have to set this also on a diesel generator solution, because it's not just a frequency watt curve, it's also an extended voltage and frequency limit that we can operate on. Yeah, display navigation, very easy for that matter on the snap inverter, and also very easy on the, or even easier on the Gen 24 and Tahoe products. Yeah, and the last question would be, why should you choose Fronius for such a solution? I want to give you a few bullet points for that matter. The first one would be, we are still a family-owned business since 1945, which for me personally is always a good hint that something is working right. With a family-owned business, we are not positioned on the stock market. We are not dependent on what the global stock market indicates, but we are separately working on what solution fits best for us and how we can we keep growing and so on. It's made in Austria, in Europe, so high quality products, and we have already 30 years of experience in the solar industry. So 1992 we started with the solar inverters and have gained a lot of experience, I would guess, from or in this period of time. We have a good service and the support. Again, no finger pointing with third-party units like Victron, for example, and outstanding product design to withstand harshest conditions. So you can install everywhere. Doesn't matter if it's the north of Canada or in the desert, you would be able to install our products there. All right, so we are finished for now. I want to thank you very much for joining this webinar today. I hope it was interesting for you. I hope you got answers to your questions, and I would be happy to greet you again in another webinar, in an online training, or even on site here in Wels in one of our next face-to-face trainings even. So in this regard, I want to thank you again once more for joining us today. And we would just turn off microphone and camera for now in order to answer your, or to focus on your questions off camera. And don't worry, you will get the answer in writing then. So thank you very much and see you next time. Bye-bye.